Welcome to the deep dive. Today, we're getting into something really practical. We're looking at network security concepts from the Aruba Certified Network Security Professional exam, the HPE7-A02.
Right.
We're using the Aruba Network Security Professional exam questions and answers material, but, this isn't just about cramming for the test.
Not at all. It's more about pulling out the real-world knowledge. How do you actually configure and troubleshoot secure access with Aruba tools?
Exactly. So whether you're actually going for the cert or, you just want to understand modern network security better, this should be useful. Let's jump in.
Sounds good. Think of it like looking under the hood, right? We see the exam question, the answer, but we want to know why. How does it actually work?
Right. Because understanding the principles helps whether you're in an exam room or, frankly, dealing with a network issue on a Tuesday morning.
Precisely. Practical insights you can actually use.
Okay, first topic. Let's say you're setting up ClearPass Policy Manager CPPM. You need it to authenticate users against your Active Directory. Basic stuff, but crucial.
The question is, what's the one configuration step that's absolutely required for CPPM to even talk to the AD server?
Okay. And the source material points to answer B. Add the AD domain as an authentication source and join CPPM to the domain.
Right. Add it and join it. Seems pretty fundamental, like you have to connect the wires first.
Yeah.
But why exactly is joining the domain so important here? What does that step actually do?
Well, joining the domain, it establishes trust. It creates a secure channel. It basically gives ClearPass the credentials, the permission to query Active Directory directly for usernames, passwords, group memberships, all that stuff.
Okay, so without that join, ClearPass is just kind of shouting from the outside?
Pretty much. It can't leverage that central AD database effectively. You need that join for unified identity management. It's foundational.
Got it. And the other options listed, why aren't they the right answer for this specific task? Like option A, ClearPass guest operator profiles. Yeah, guest operator profiles are really for, well, guest access. Temporary users. It might use LDAP, sure, which AD speaks, but it's not the same as integrating your main domain users.
Okay. And C was enabling TACAX Plus on the AD server.
Right, TACAS Plus is a different protocol. It's usually for controlling who can log in and manage network devices, like your switches or routers.
Yeah.
Not really for authenticating end users connecting to the network via ClearPass in this way.
And the last one, D, SNMP community strings.
SNMP. That's all about monitoring. Checking the health of the server, seeing if it's up, how busy it is. Nothing to do with verifying user identities for network access.
Okay, so bottom line. For ClearPass to use AD for user authentication, you absolutely have to join it to the domain first. That creates the necessary trust and communication path.
Exactly that. It's the handshake. It lets ClearPass work with AD to figure out who's allowed on the network.
All right, moving on, let's talk troubleshooting. Scenario. A device connects, everything seems okay physically, but it just doesn't get the right network access. It's failing to match any ClearPass enforcement policy.
Yes, a common headache.
Where's the first place you'd look to figure out why?
The source points to A, and frankly, it's where you should always start. Check the access tracker logs in ClearPass.
Access tracker. Sounds like the place to be. What makes it so vital for these kinds of policy issues?
It logs, well, basically everything about each authentication attempt. You see the device, the user, how ClearPass evaluated the connection against your policies, which rules it checked, which ones it matched, or, importantly, didn't match.
So it's like a step-by-step replay.
Exactly. It shows the decision process. If there were errors, maybe fetching user info, or if the device attributes didn't match any policy condition, Access Tracker will show you exactly where things went wrong. It's your primary diagnostic tool for policy problems.
Okay. And why are the other options less direct for this particular problem, like syslog from the switch?
Syslog from the switch, it might show you the device connected at a very basic level, like the port came up, but it won't have the details of the ClearPass policy evaluation. That logic happens within ClearPass itself.
Right. And option C, network scan from OnGuard.
OnGuard scans are more about posture assessment. Is the device healthy? Does it have the right security software? That's important, sure, but it doesn't directly explain why an initial access policy isn't being matched during authentication.
Okay. And D was ARP protection.
Yeah, ARP protection is a security feature against spoofing attacks. Very different thing. It wouldn't cause a device to simply not match any standard access policy.
So for policy matching problems, Access Tracker is really the command center. It shows you ClearPass's reasoning.
Precisely. It's the log file specifically designed for exactly this kind of troubleshooting. Your first stop, always.
Okay, let's switch gears slightly. ClearPass Device Insight, or CPDI. How does integrating that with ClearPass Policy Manager actually help? What's the main benefit?
The big advantage, and what the source highlights with answer C, is that it really enhances device visibility. It does this through behavioral fingerprinting and classification.
Behavioral fingerprinting, that sounds detailed. What does that mean for network devices?
It means CPDI isn't just looking at, say, the MSE address, OUI, the vendor identifier, or what the device might claim to be via DHCP. It actively watches how the device communicates on the network.
Watches how?
Like, what protocols does it use? What servers does it talk to? How often? Is it sending lots of small packets or large chunks of data? By analyzing these patterns, these behaviors, CPDI builds a much richer profile, a fingerprint. This lets it classify devices much more accurately. Like, it can tell a specific model of IP camera from a smart thermostat, even if they don't clearly announce themselves.
Okay, so it's learning from observation, not just taking the device's word for it. How does that help with security policy?
Well, this deeper context is gold for CPPM. You can write much smarter, much more granular policies. For example, you know exactly what kind of traffic a specific IoT sensor should be generating. So you can create a policy allowing only that specific behavior and blocking anything else. Much tighter security.
I see. Rather than a generic IoT device policy, you can get really specific based on observed behavior.
Exactly. And what about the other options for CPDI integration? Why aren't they the main point? Like option A, pushing enforcement policies.
CPPM does the policy pushing. CPDI provides the intelligence, the detailed device context to CPPM so it can make better policy decisions. CPDI itself isn't the enforcement engine.
Okay. And B, acting as a backup radius server.
Nope, that's not CPDI's job either. CPPM handles all the radius functions.
And D, configuring VLANs.
Again, that's CPPM's enforcement role. CPPM assigns the VLAN based on the policy, but the intelligence to choose the right policy and the right VLAN can be significantly boosted by the insights from CPDI. So CPDI adds the deep who and what understanding, focusing on behavior, which lets CPPM do its job of controlling access much more effectively.
You got it. Better visibility leads to smarter, more secure policies.
All right, next up. EAP-TLS authentication in ClearPass. Strong security, but it relies on certificates.
Mutual certificate authentication.
What's the absolute must-have condition for ClearPass to successfully validate a client certificate?
Okay, according to the material, the key is B. The client certificate must be signed by a certificate authority, a CA, that is trusted by CPPM.
Right. The CA, the trusted third party. Why is that trust relationship so non-negotiable for EAP-TLS?
Well, think about it. EAP-TLS uses certificates to prove identity. The client proves itself to ClearPass, and ClearPass proves itself to the client. For ClearPass to believe a client certificate is legitimate, it has to trust the organization that issued it the CA.
How does it establish that trust?
You typically upload the CA's own certificate, its root certificate, into ClearPass's trust list. If the CA that signed the client certificate isn't in that list,
then ClearPass has no reason to believe it.
Exactly. It can't verify the signature, can't trust the certificate, authentication fails. It's all about that chain of trust back to a known, trusted root.
Okay. And what about the other options? Any pitfalls there? Option A mentioned key usage, digital signature only.
Digital signature is very common, often required, yes. But it's not necessarily the only key usage allowed or present, so stating it must be only that is too restrictive. Other key usages might be fine.
Gotcha. Option C suggested the certificate must match the device's MAZ address.
Generally, no. Certificates are usually tied to a user identity, like an email address, or a device identity, like its hostname, not usually the hardware MAZ address.
Okay. And D, only certificates from Aruba certificate services.
Definitely not. ClearPass is vendor agnostic here. It can trust certificates from any CA public ones like DigiCert, internal enterprise CAs, as long as you configure ClearPass to trust that specific CA.
So the core principle is simply, ClearPass must trust the issuer of the client certificate. Without that trusted relationship, the certificate is essentially worthless for authentication.
Precisely. It's like showing a passport. It only works if the border agent recognizes the country that issued it.
Okay, final area today. Let's talk about roles in ClearPass. We authenticate a user or a device, and then ClearPass often assigns it a role. What's the main purpose of doing that?
The fundamental purpose, and the answer is C, here's it, to determine what level of access the user or device should receive on the network.
Roles. So they're like labels that dictate permissions.
Yeah, that's a good way to think about it. Labels are tags. After ClearPass authenticates an endpoint, it looks at various factors: who the user is, maybe the department from AD, what type of device it is.
Like, is it corporate-owned or personal?
Right. Or the results of a health scan from OnGuard, maybe even the time of day or network location. Based on all that context, ClearPass assigns a role, like employee corporate laptop or contractor guest Wi-Fi or IoT camera.
And then that role dictates everything else.
Pretty much. The role becomes the key input for your enforcement policies. The policy says if the role is X, then assign VLAN Y, apply firewall rule Z, maybe limit bandwidth. Roles are how you translate identity and context into actual network access privileges.
Okay, so roles are central to applying the right access controls. Why aren't the other options the main point? A was about SNMP communities.
SNMP communities are for network management, for monitoring devices. They aren't directly used by ClearPass roles to control user or device network access. Different purpose.
Right. B mentioned controlling access based on user credentials.
Well, user credentials often influence the role assigned, yes. But the role itself is broader. It can incorporate device type, health, location things beyond just the username password. And the role's purpose is the resulting access control.
And D, grouping MA addresses for reporting.
You could potentially use MASI addresses as part of assigning a role, maybe for some static devices. But the primary function of roles isn't just grouping for reports, it's actively defining and enforcing network access levels.
So roles are the core mechanism ClearPass uses to implement granular, context-aware access control. They bridge the gap between authentication and enforcement.
Exactly. They let you implement least privilege, giving each endpoint only the access it absolutely needs based on who or what it is and its current context. It's fundamental to how ClearPass manages security.
Really internalizing these concepts help tackle those. Something to chew on.
Thanks for joining us on this deep dive.